All right, so you can see, starting the second video here, just to try to kind of split up the break in case you needed a little breather or anything. We're going to skip right through the warm-up since we've already done the first lesson, which is 6.4. We're right into 6.5, which is understanding decay. And yeah, just kind of getting right to it. So here's one way to think about how much Diego has left after spending 1/4 of $100. So he spent a fourth, right? There's a couple ways to think about it. All right, number one, he had $100 and then he subtracted a fourth of that $100, right? Or you could write it with parentheses because you could factor out a GCF, greatest common factor, like we've talked about in the past. You probably even talked about it in 8th grade, right? You have 100 here and 100 here. Excuse me, let me let that go away. So if I take that 100 and I factor them both out, so you'd have the 100 out front, and that would leave you with 100 times 1 minus 1/4 when you factor out that 100, which is where they get this. So realistically, what's left, what I want you to realize is when you are talking about exponentials and you're saying that you're going to take away 1/4, when you go to multiply, it's not going to look like this because you took away a fourth. So instead of multiplying by a fourth, you have to multiply by what's left over, which is this step right here. So this one would be wrong. This one would be correct. So we'd want it to look like this. Okay. Now, you could write it in any of these formats. You could write it like step 1. You could write it like step 2. You could write it like step 3. Heck, you could write it like step 4. All right. It doesn't really matter. All of them are feasible options. Okay. And so we've got some examples here. Number 2 says a person makes $1,800 a month, but 1/3 of that amount goes to her rent. What two numbers can you multiply to find out how much she has left after her rent? Well, if she's taking away a third, how much is left? 2/3, right? So 1,800 times 2/3 is going to give us her total. Okay, how much she's got left. We'll just say that that's a T, I guess. Right? Number 3, write an expression that uses only multiplication and is equivalent to x reduced by 1/8 of x. So it's the same idea, but you're going to say it's x reduced by 1/8 of x. So it'd be like times 7/8 of x. Right? Or you're taking away 1/8 of x. 1/8 times x. So it'd be like x minus 1/8 of x. Okay, or another way to write that, you could take the x, factor it out, and say it's x times 1 minus 1/8. Okay, all right. So this is the big one we talked about the other day, the value of a vehicle. The minute you drive a new car off the lot, it depreciates in value because it's no longer classified as a new car, but rather it's now classified as a used car. So this is where in exponentials, they really try to forecast how much of that value of that car is going to be. So for instance, if you get into an accident before you've paid off the loan, then you're going to owe the difference on that car, and you're going to have to owe the more money than what it's actually worth, right? So you're going to have to pay even more onto the vehicle. Every year after a new car is purchased, it loses 1/3 of its value. So let's say that a new car costs $18,000, right? A buyer worries that the car will not be worth, will be worth nothing in 3 years. Do you agree? And this is what you have to remember. The answer here is going to be no. And the reason why is as you get down closer to the zero, right, with an exponential decay, it doesn't actually ever hit 0 on the y-axis. But this is y and this is x. It gets closer to it, but that car is not going to be worth nothing. I mean, even if it's not a very good car, it's a hunk of junk, you can take it to the scrapyard and get some money out of it. It's never going to be worth 0. Somebody's going to pay you something for it, even if it's just for parts. Okay? So it's always worth something. That's a W. I don't know why it's looking like that. Okay? It's always worth something. So if the car loses 1/3 of its value every year, how much is the car still worth at the end of each year? Well, it's going to be worth This is where they're asking you basically to write the expression, right? So if it's losing 1/3 of its value, so its initial value, but it's minus 1/3, right? And let's say it's initially 100%. Well, minus 1/3 would be, we want to write that as a 1.0, sorry, 100%. Okay, that would be 2/3. So it's still worth 2/3 of its value every year. Okay, so we're going to figure that out. So if a car starts at $18,000 and after 1 year it goes down to 2/3 of its value, what is 18,000 times 2/3? It is 12,000. What is 12,000 times 2/3? That would be 8,000. Okay, what is 8,000 times 2/3? Ooh, that's not a pretty number. That's going to be 16,000 divided by 3. So it's like 5,333 and some change. Okay, now that's the third year. Now what about the sixth year? What about the T year? Well, this is where we would, write the function. And we would say that it is started at 18,000 and it goes down 1/3 every year. So it'd be 2/3 of its original value to the T power. So when I plug that in, there we go, times 2/3 to the power of, we'll say x, even though we wrote T. Okay, I click my table, and you can kind of see third year, we were right there. Sixth year, $1,580.25. Okay, and so it really starts depreciating the more years that you have it, right? We went from $18,000 for the car, $12,008, $5, and then just over $1,000 after 6 years. Okay, and certain vehicles will retain more value. Like if you have a truck, it usually maintains more value. It might not go down 1/3. Maybe it's more like 1/4 because they resell better. But that's just, the nature of the beast. So then it says, write an equation. We already did that, but just so we can write it one more time. It was V equals 18,000 times 2/3 the power of T. And I'm only using V and T because it says V, because it says T right there. So I'm writing it the way it requested. And then it says, use your equation to find V when T is 0. Okay, we talked about this one yesterday. What happens when you have 0 as an exponent? It's 1. I know you're going to say 0. It's not. So it'd just be 18,000, which makes sense because that would be when you first bought the car, right? So what does V mean in this situation? It is the value of the vehicle at new price. Okay. A different car loses value at a different rate. The value of the different cars in dollars D after T years can be represented by this equation. Explain what the numbers 10,000 and 4/5 mean. So 10,000 we know is the starting price of the car. And then 4/5 means that's how much, or, well, it's the growth factor, right, or decay factor. But also, it's the percentage of the value left, or the, what do we want to say? The fractional amount of car's value. Okay, so you take 10,000, you multiply by 4/5, that's how much it's still worth. All right, let me take a look real quick. No, that's it. All right, sorry about making 2 longer videos, but I want to make sure that you had all the information leading up to the quiz. That is exponential decay. We kind of combined 2 different lessons there. If you have questions, feel free to reach out. Otherwise, good luck, and I will see you guys on Tuesday.